This is day 14 of Unit 7. We started today with a ticket, so you'll need to get that made up if you missed class. Also, we had a warm-up, so take a moment, pause the video, do the warm-up, and then play to check your answers. So this one I've already done. Just show that. So setting the equation y equals a times b to the x minus 4, putting negative 4 in for the asymptote, then substituting x and y in to form two equations, adding 4 to each side to get two equations that have both an a and a b. Solved this equation for a, substituted that a value back into the other equation for a, simplified and got that b is 1/4, then substituted 1/4 back into the equation that was solved for a to get the a value, which is 8. Final answer, y equals 8 times 1/4 to the x minus 4. Okay, so today we looked at solving systems of equations involving exponential functions. And what you need to know is that when you have exponential functions as part of a system, the system cannot be solved algebraically. So if you recall, when we solved systems of linear equations, we had several different techniques. We had graphing, we had substitution, elimination, we had matrices, we had Cramer's rule, we had several different ways. Well, with systems of equations where one of the equations is exponential, all of the algebraic approaches are out. So the only thing that's left is solving using graphing. When you get to calculus, you'll learn some techniques for solving exponential equations, systems with exponential equations, but there's no algebraic approach. So just you want to make a note in your notes that because this system has an exponential equation as part of it, it cannot be solved algebraically. So the only way we can solve it is by graphing. So I'm going to go to my graphing calculator, and I'm going to enter in the two equations. So I have y equals, clear anything that might be in there, so 3 to the x minus 8. And looks like I missed the first equation, so then we'll just put x minus 5 in the first spot. X minus 5 is the other one. And I'm going to do a standard window, so zoom standard, and there's my graph. Okay, so remember to find the intersection points. We did this early in the year. There's two different points here. I'm going to do second and then calculate, intersect number 5. First curve, I'm just hitting enter because it's already on the first curve. Second curve, enter. My guess, I'm going to move it to this point of intersection and enter. And I'm getting the first solution. So I'll just go ahead and write that 1.34 and negative 3.66. 1.34 and negative 3.66. So that's my first solution to this system of equations. So let's get the other. So I'm going to do that process again. So second, calculate. Number 5, intersect. First curve, enter. Second curve, enter. Guess, putting it over, using the left arrow to get it over to this other point of intersection right about there, and enter. And the intersection is negative 2.96, negative 7.96. And those are my solutions, okay? No work shown because the calculator did all of the work for us. So those are the two solutions to that system of equations. So let's take a look at the second example. So go ahead and copy that into your notes. And then just going to write this down here, and then we'll go ahead and enter that into our calculator. So square plus 1, there's my equation. Just now I'm able to enter it into my calculator. So once again, y equals, I'm clearing what's in there. Let me go ahead and clear my history here so we can see. So I'm going to go ahead and enter the first equation, which is 3 times 0.5 raised to the x and then plus 2. And the other equation is x minus 4, the quantity squared, plus 1. So graphing those, now clearly the two graphs intersect at least 2 points. I can see here and here there's at least 2 points of intersection. So I'm going to go ahead and calculate those a while, and then I'll see if I can't tell using this standard window, but it looks like maybe up here there could be a third intersection point. So I'll have to adjust my window so I can see that before I can find that one. But let's get the two that we can see on the screen. So I'm going to go through that second calculate intersect twice to get the 2 points of intersection. So second, trace button, intersect number 5, enter, enter, and then I'm moving the cursor to that first point of intersection there, right about there, enter, 2.8, 2.43. Okay, so let's go back here to get the other one. Second, trace, intersect number 5, first curve, second curve, enter, enter, guess, moving it over to that second point of intersection right about there, enter, 5.04, 2.09. Okay, so now I'm going to go back to my calculator one more time. I'm going to adjust the window so that it's up higher so I can tell if there's another intersection up there above the screen or not. So I'm going to go to window. And again, I'm not really sure how to set the window. I'm just kind of guessing. I know it needs to be, the Y max needs to be higher. So I'm going to try 100 and see what happens as I get higher. So it looks like, yep, there's another intersection right there. So we're going to figure out where that is. So second, trace, number 5, intersect, enter, enter, and now I'm using my cursor to get it up to that point of intersection. Right about there. Enter. Negative 4.6, 75.07. Actually, negative 4.61, 75.07. Okay, so I have 3 points of intersection. So once again, if you're only seeing 2, you have to adjust your window so that you can see if there are any others. Now, on the very first example we did, it was obvious that there were just those 2 because the curves were going in opposite directions, so clearly they weren't going to intersect off of the screen. This one, though, in our first window, in our standard window, it was hard to tell. So you need to adjust the window so you can see the rest of the graph, and then you're able to find that third point of intersection. Okay, so let's look at our last example for today. So go ahead and copy that into your notebook, type that into your calculator. Okay, so now I know what the equation is. I'm going to go ahead and type that in. Go to y equals, clear that, clear that. I'm going to go ahead and enter my equations now. So I have 2 to the x plus 2. And then we're going to subtract 6. And the other is quantity x minus 3. quantity x minus 5 and quantity x plus 3. Okay, enter. We're going to graph. We'll just graph it using that same window we were on. So I think we're still at 0. We're at 100 for the max. Okay, there are clearly 2 points of intersection for sure, possibly a third up there in that upper right corner. So I'm going to calculate intersect, enter, enter, move my cursor down here. And now it's not going exactly on, but that's okay, as close as you can get to that point of intersection. So negative 3.11, negative 5.54. Okay. 5. Yep, 5. Okay, second. Calculate again, intersect, enter, enter, guess. Looks like that's as close as I can get it. Enter. 2.17, 12.06. Okay. And again, possibly there's a third. I can't tell based on how those curves are angled. So I'm going to have to adjust my window so that I can get a better look. So I'm going to try maybe 500. It's looking like they're not going to intersect. Okay, the way that they're angled, it's not going to happen. So there's only these 2 points of intersection for this one. And that's it. So you're going to do that homework for tomorrow. Next week you have a quiz coming up. Your packet will be due.